Today, we're so excited to be introducing this new way of model customization for our O1 series of models, reinforcement fine-tuning, or RFT for short. For the first time, developers, researchers, and machine learning engineers will be able to use reinforcement learning to create expert models capable of excelling at their specific tasks within their domain. We believe that any field which requires deep expertise in their AI models stands to benefit. So if you work in, say, legal, finance, engineering, insurance, this one's for you. For example, we recently partnered with Thomson Reuters to use reinforcement fine-tuning to fine-tune O1 Mini to be a legal assistant in their co-counsel AI. This tool assists their legal professionals in accomplishing some of their most analytical workflows.
Yeah, so some of you will be familiar with the supervised fine-tuning API that we launched early last year. And supervised fine-tuning is really powerful. What you're trying to do is get the model to replicate features that it finds in input text or images. And this is great if you want to change the tone or the style or the response format of the model. Now, with reinforcement fine-tuning, or reindeer enforcement fine-tuning, as I should say, with reinforcement fine-tuning, it's different. So you're not just teaching the model to mimic its inputs. What you're teaching it to do is to learn to reason in entirely new ways over custom domains. And the way this works is that when the model sees a problem, we give it space to think through the problem, and then we grade the final answer from the model. And then using the power of reinforcement learning, we reinforce lines of thinking that led to correct answers, and we disincentivize lines of thinking that led to incorrect answers. And what you'll see is that, with as little as a few dozen examples, the model will learn to reason in new and effective ways over custom domains.
That's crazy that you can do that with just 12 examples. That's not something you can do with regular fine-tuning.
Yeah, exactly. Yeah, I mean, in the space of large language models and large machine learning, a few dozen examples is basically nothing. Yeah, so for the first time, our model customization platform will support reinforcement learning. And notably, this is the same technique that we use internally at OpenAI to train our frontier models like GPT-4o and the O1 series.
One area with many exciting applications is scientific research. But don't just take our word for it. That's why we're joined today by Justin Rees. Justin is a researcher at Berkeley Lab, and one of his areas of study is using computational methods to understand the genetic causes underlying rare diseases. Justin, thank you so much for being here. Do you mind telling us a little bit more about your research and how reinforcement fine-tuning might help?
Sure, thanks. It's great to be here. So one of the areas of my research is rare genetic disease. So contrary to the name, rare genetic disease is actually not rare. So any one rare disease is rare, but if you put them all together, they're actually quite common. And so we're talking about 300 million people globally who suffer from a rare disease. And what's more, these people often have a long diagnostic odyssey of months to years before they find out about their condition.
Well, it's like the whole population of the US.